All right, as promised, this video is going to be graphing the transformations of the log function. So the very first thing we're going to do, just like we did with exponentials, we're going to identify the base as being greater than 1 or in between 1 and 0. And clearly, since 3 is greater than 1, we are going to have a situation in which we are going to have growth from left to right. So it is increasing from left to right. So that's what the parent graph looks like. But now, if you'll notice, we've got some transformation happening here. We essentially have negative x plus 2 right here. So that indicates to me that I am going to reflect across y. And this means that I am actually moving right 2, because if I solve this, if I set it equal to 0 and solve, I end up subtracting 2 from both sides, and then x equals positive 2. So it is going to be right 2. All right, so if we think about what the parent looks like, right, something like that, since we are moving to the right 2, that means that this asymptote here at the y-axis actually moves to the right 2, just like that, which means the graph would also move to the right, just like that. I'm going to try to erase some of this so we don't get too confused. All right, so now that takes care of my right move. Now I'm going to reflect over y. So that means this point goes right here, and I end up having a graph that looks like that right there. All right, so it may help to draw it in stages like that. And so I've got my x-intercept at 1, 0. So my domain is now negative infinity up to positive 2. And my range is everything, negative infinity to positive infinity. My asymptote moved from x equals 0 to x equals 2. It is now decreasing from left to right, so from negative infinity to 2, it is decreasing. The x-intercept is 1, 0. There is no, we do have an x-intercept, sorry. We have an x-intercept right up here. This involves using your equation to find that value, which means we're essentially finding what y is when x is 0. Now, this entails a little more arithmetic that I'm going to require of you. I'm just showing you where it would come from. So we would essentially be solving for that right there, but we are not going to go into that much detail for these problems, so we're just going to use that x-intercept as an anchor point and talk about that one. So it is not increasing from left to right. The end behavior, remember, is occurring right up here. So as x approaches negative infinity, y approaches positive infinity. And the asymptotic behavior, which is occurring right here, is going to be as x approaches 2 from the negative direction, y is approaching negative infinity. So that's what that's going to look like. Okay, let's look at the next question, or the next example, I should say. All right, this is natural log. So again, we need to identify the base in order to determine what the parent would look like if it's increasing or decreasing. So if you will remember, log is in the base of e, and e is the Euler number, which is 2.718 approximately. So that means since e is greater than 1, that means that we have a situation where we are increasing. So that's what the parent would look like, something like that. So what we're going to do is we're going to identify the other transformations that are happening here. We have a negative out front. That means that we have a reflection across x. And since we have x plus 1 inside parentheses, that means we're moving left 1. All right, so let's take this step by step and see what this would look like. Since my asymptote is understood to be at the y-axis, I know this is going to move left 1, so that's where the asymptote's going to be. That means that this graph is essentially going to move over to right there, and then it's going to reflect across x. So the graph is actually going to look something like that. So let's clean this up. You've seen where I got that. Oh man, look, I undid it, yay. Okay, so that means that my x-intercept and y-intercept, these are both easily identified this time. So they are both at 0, 0. My domain is going to be from -1 to positive infinity. My asymptote is at x equals -1. The range is negative infinity to positive infinity. It is decreasing from -1 to infinity. It is not increasing. End behavior right here. As x approaches positive infinity, y approaches negative infinity. Asymptotic behavior right up here. As x approaches -1 from the positive direction, y approaches positive infinity. Okay, and our last graphing example, I'm going to identify the base here. It is 1/2. That means that since 1/2 is less than 1, we have a situation in which we are going to have decrease from left to right. So that means that's where our parent begins. And then if you will look at this transformation, it means that we are moving left 2. So we don't have any reflections or anything for this one. So my initial graph would look like that, but I'm moving left 2. So the asymptote moves left 2, and this ordered pair of 1, 0 also moves to the left 2. Okay, so there's my original. I'm going to get the hang of this eventually. Maybe. All right. So -1, 0. The domain now is -2 to positive infinity. The range is all real numbers. The asymptote is at x equals -2. We are decreasing from left to right. The x-intercept is at -1, 0. The y-intercept involves some calculation with log. We're not going to do that right now. It is not increasing. End behavior, remember, occurs right here as x approaches positive infinity, y approaches negative infinity. And for the asymptotic behavior, as x approaches -2 from the positive direction, y approaches positive infinity. There you go, babies. I hope everybody enjoyed log graphs. Now we're going to do applications. Yeah.